Okay, section 6.3 is called the central limit theorem. It brings in samples where the other problems we had were talking about populations. A sampling distribution of sample means is a distribution using the means computed from all possible random samples of a specific size taken from a population. The central limit theorem says as the sample size n increases without limit, the shape of the distribution of the sample means taken with replacement from a population with mean mu, standard deviation sigma, it will approach normal. The distribution will have a mean of mu and a standard deviation of sigma divided by the square root of n, because you have to bring in the fact that it's a sample. The formula for the z-score this time is a little different. Is the mean minus, or the sample mean minus the population mean divided by the standard deviation over the square root of the number of items in the sample. Okay, let's see what we can do with this. So let's look at a couple of problems. We'll be on page 352. Let's look first at number 11. Okay, number 11 says, the mean serum cholesterol level of a large population of overweight children is 220 milligrams per deciliter. All right, that's our mean. Okay, and in fact now this is our actual population mean. Okay. All right, let's read on. It says the standard deviation is 16.3. If a random sample of 35 overweight children is selected, so that's your N, it says find the probability that the mean will be between 220 and 222. It says assume it's normally distributed, okay? So I have to find the z-score of 220 and 222, okay? Now this was a different formula, remember it was the mean minus the population mean over the standard deviation divided by the square root of n. So that would be 220 minus 220 divided by 16.3 over the square root of 35. I'm going to round to the nearest hundredths place. That's going to be 0. I'm going to do the same thing with the 222. Okay, plug it in, round, that's 0.73. Alright, it says between those two, so I have to go back to my z-score chart that we've been using all this time. I'm going to look up a z-score of 0 and a z-score of 0.73. I will subtract those to get my final answer, which is 0.267. Okay? Okay, let's do one more problem. Let's do number 15. Okay, 15 says the average overseas trip cost is $2,708 per visitor. That's the population mean. Okay, so that's mu. If we assume a normal distribution with a standard deviation of 405, what is the probability that the cost for a randomly selected trip is more than $3,000. Okay, let's stop right there because this problem has two parts. This is the old z-score formula. So I'm gonna plug in 3,000 minus 2708 divided by the standard deviation. Now you might be thinking, well, how did you know that? I knew that because they didn't mention anything about the a sample size or anything to that effect, so I had to use that regular old z-score formula. Okay, go to my z-score chart, look up 0.72. I gotta subtract it from 1 because it said more than. So my answer to the first part is 0.2877. Okay, go back to 15. Let's look at the second part. It says if we select a random sample of 30 trips, so now my n is 30, and they're fixing to describe the means of those 30. It says, find the mean of the sample. What's the probability that the mean is greater than 3,000? So now this time, I'll plug into the other z-score formula. So that's going to be 3,000 minus 2708 divided by the standard deviation over the square root of n, which is the square root of 30. Punch it in. I get a z-score of 3.95. If you go look, if you go try to find 3.95 on your z-score chart, it's outside of the range of values. So that means it's going to be less than that smallest probability on that z-score cheat sheet, which is 0.0001. Okay, if you got any questions, please let me know.